Yeah, hi, welcome everybody. So I hope I will keep you awake, although it's already in the evening and second conference day. Thank you for joining. So my topic today will be from machine learning startup to big data company. And while it will be probably a little less technical than many of the talks that you've seen here so far, I still hope that you will be able to gain some relevant insights. And before we get started, I'd like to get to know you a little better. So maybe a little hands up round. Who of you is currently working in a startup? Yeah, at least some. Who would say that he's working in a sort of an established company? Oh, more. Maybe due to the fact that it's a big data conference. Who's working with machine learning? Okay, also quite a lot. And who's working with Hadoop, like anything from the ecosystem? All right, good. So yeah, in my talk today, I want to share some lessons that we learned while founding and scaling a machine learning startup. And in particular, I want to talk about all the major mistakes that we made. So if you happen to still be in a startup phase, then you can maybe avoid them. Before I get started, no, how does it work? Okay. Yeah, I'm Christoph, and that's me in San Francisco, where I had a great holiday recently. I got into developing in about 2001, and I still yet decided to study physics after school. And I also finished my bachelor's degree, and then sometime in 2011, while I was doing my master's studies, there was this great and interesting startup opportunity, and this is basically also where the story begins. So back then, I was getting in touch with a few physicists. They were doing research in machine learning for about, I guess, something more than 10 years at that point in time. Because, I mean, a lot of stuff that you do in theoretical physics is what you would nowadays call machine learning. They were particularly into clustering, and it was already some years ago that they had done an interesting research on a large online market, which was eBay. And then they realized that with their machine learning techniques, they could find out lots of stuff about the behavior of users on this market. And they said, hey, our algorithms actually seem to be really, really useful for marketing. We should make money with it. And they had the idea that basically all it takes is just to build some API around it, and you have a great product because we have great algorithms, and we will have a useful product. And to do this, they basically found some business guy for the making money part, and they found me for the just building an API part, and we founded a company. And well, at that point in time, I thought, sounds great, making money, but with just building an API, I should do that. So I decided to quit my university studies and started that startup. And as it turned out, well, not quite. So the first thing that this business guy and me, who were basically actively starting the startup, was like finding a product. I mean, we had great algorithms, we knew kind of what to do with it, but we didn't really have a product yet, and we had to find out about it. The first thing we did was building recommender engines. You know that from e-commerce sites. You recommend some products. It was relatively easy to start with, straightforward. We had good results. We also got in touch with some test customers who were willing to include our technology. We could do a quick go live, but we also realized that with each new customer that we wanted to implement with, we had a lot of effort, and we realized it simply wasn't a business that we could really scale, because it was just too much effort for too little money. So actually we found out that it wasn't really about finding a product to make use of our machine learning algorithms. It was rather about finding the right product. And what we then did is we went a lot to conferences. presented the concepts that we had. We talked to potential customers, and we were actually trying to find a product that also scales business-wise. And it was at some conference here in Berlin as well, the next conference, where we got in touch with somebody from online advertising, from a company called AdMeld, who says, well, our marketplaces in online advertising are incredibly inefficient, and we need machine learning technology like yours to make this more efficient. So we got involved with this company and wanted to start a project with them, which didn't work out, unfortunately, because they were acquired by Google, but it showed to us that it's actually apparently a market where you can build a business that scales. So basically, we settled down to building a real-time bidding system for online advertising. But that also came with a cost that we realized, wow, now we have to build even more infrastructure, and it's even further away from the initial idea of just building an API around some algorithms. So, and that's basically my first lesson learned from an algorithm to a product. So if you're coming from this maybe scientific or tech side and think you have great technology, but you want to make money with it, the first crucial thing is to find out about your actual product. Because even if everything is great and revolutionary, that doesn't mean that you will immediately make money with it. You really have to build a product with it. And also one of the key lessons was that probably we would have been a lot faster if back at that time we would have found somebody from this field, from online advertising, to get into the startup team. Because we had basically to find out about all the needs of our product the hard way, by talking to customers, by making lots of mistakes, and fixing them. If we had somebody at that point in time who was more into this whole thing, we would probably have been a lot faster. So let me come to the 3 stages of a machine learning company that we have identified during the course of the year. So first stage, I would call the bootstrapping stage. And I always have put up pictures of our offices onto these slides. So this was basically 2 or 3 people sitting in a room trying to find the right product first, and then trying to build a proof of concept. And don't worry, these beer bottles were not always on this desk. And then we somehow managed to build this proof of concept. And then the next challenge is to enter the market. And at that point in time, hopefully your proof of concept shows enough the power of your innovation that you will convince some venture capitalists to give you some money. Because, I mean, you might make it without them, but in many cases you simply need more resources to be able to enter the market and to start making customers happy. So you will need some venture capital. And this is basically the stage 2, where it's really about to establish your product, get into the market. And then eventually, if you're successful with that, you will get more and more customers. This will also mean you will gather more and more data. And hopefully you will have the need for scaling your product. And of course, you should also add some more features, make everything more robust, etc. And this is basically the point in time where you get in this big data region. So quick summary, the 3 steps. Bootstrapping, find a proof of concept. Funded startup, make the market entry. And big data company, it's all about scaling. So now, what is the structure of a machine learning company? Well, first of all, you need a team. I will briefly talk about it in the end. You need a product. I already talked about it. And you need an architecture, because this is what it's all about. And since this is also a tech company, I want to also focus on this technology part for the rest of my talk. And I think you have seen similar images to that already quite a lot of times in other talks on these conferences, because this is what typical architectures for machine learning stacks look like. So you have some source of events. I heard the term Internet of Everything yesterday, because it can be like the classical internet. It can be Internet of Things, sensors, stock market data, whatever. So this is the outside, this is where the data comes from. Then you usually have some real-time component which accepts these events, and which is basically the gateway into your internal architecture. Then these events are somehow promoted into a pipeline where they are processed, and they are usually also stored. And then in the case of a machine learning company, you will have some machine learning algorithms that make use of this data, be it in a batch fashion by accessing the stored data, or in a streaming fashion by simply listening to these streams. And they will do some math, generate what I called models in this slide, and feed that back into the real-time part, because, of course, you want to answer questions from the outside world in real time, do predictions, if you will. What was that in our case? Or for the rest of the talk, I mean, basically, I think any of these parts would be a talk on its own, so I will focus on the data part for the rest. What was it in our case? So the product was a real-time bidding engine. So the data source is the internet, classic internet. Our real-time component consists of a bidding engine and a tracking engine. These events are received and, and processed and stored. And our models are predictions for clicks, conversions, and that sort of stuff. Yeah, maybe a very brief interlude. What is real-time bidding? Maybe some of you have seen the presentation by Criteo yesterday morning. Well, many website owners, or most website owners, actually make their money selling ad spaces. So you have a dedicated space on this website that is sold for advertisement. And how that usually works nowadays is that the request is forwarded to something called a supply-side platform, which is basically a broker that offers this ad space to a handful or a couple of hundred so-called demand-side platforms. This is what we are doing. And then we have a couple of milliseconds time to decide whether we want to buy this ad impression or not. So basically, website owners sell their ad spaces, advertisers buy the impressions. Yeah. This is what we are doing, just to show again that this has a real-time component. This round trip is bound to 100 milliseconds. And let's look at the events again, basically the events that concern us. So basically it's the bid request coming from the supply-side platform. Then we figure out if we want to buy an advertising impression. If we do so, we send back a bid. And if we happen to have placed the highest bid, we will receive the impression, and later on we can track if the user clicked or, in the best case, even bought something in a shop. So the goal for us from a machine learning perspective is to predict these clicks or even better conversions. So now let's have a look at the events, or no, let's stick for the goal for one moment. So what we have to pay is basically every impression. Each time we buy and display an advertisement, we have to pay. What our advertisers actually want to pay is only for successes, so basically only when they get a click or a conversion later on. That means that the revenue that we gain is only whenever a success happens. But so we have to figure out what we're actually willing to pay each time. And this is why we have to predict the probability of a click. And this probability of a click, of course, is dependent of lots of features, be it the user, the website where he's browsing, the browser that he's using, etc. So basically, we predict it from data. Yeah, let's go into this data pipeline now. How does this data typically look like? So it's essentially HTTP requests, which means that it comes with a cookie ID or with some user agent string, with an IP address, with the URL that this user is currently visiting, all that sort of stuff. So this is basically the raw data. And, well, it's, of course, somehow unhandy, at least for human beings. So one of the very typical steps that happens is, of course, that you take such a data point and you see what features you can extract from it. So basically from a URL, for example, you can extract a domain or even just the top private part. Or from an IP address, you can extract geo information, or you can extract the ISP that this user is currently surfing with. Or from a user agent string, you can extract information about the device that this guy is using. So basically, to summarize, the incoming events, they sort of have what I would call, they make up for the analytics dimensions. So this is basically where data scientists will look into and will try to figure out what interesting features are actually in that raw data. And then on the right-hand side, after a step that we call featurization, you sort of have these extracted features, something that also humans can actually often reason about. So for example, somebody or a customer might want to know how many impressions and clicks he or she received in Berlin in the last few days. Yeah, so this is basically the data that we are dealing with. Yeah, and now let's have a look at how this data processing evolved in the 3 stages and what we did wrong on the way. All right, so in the bootstrapping phase, you have to imagine we were just like 3 people, and we had to build such a system. So we did it, please don't laugh at me now when looking at these slides, so we did it very, very simple. We just had this real-time tracking component. It was getting these events, and it was writing them as JSON to log files. We then eventually compressed these log files and rsync them to a separate server, because we didn't want to do our math on the same server that was doing the real-time part. Then for reporting purposes, we were basically just reading these files in batches, extracting all the features that I showed you, and basically piping them into a MySQL load data command, so that we had at least some SQL database where we could generate reports. And for analytics, those who were concerned with the data science part of our product, they were actually taking entire log files, parsing them into Python, extracting the stuff from the JSON objects, and then doing their machine learning stuff with it. So this is, of course, I mean, it's obvious that this will not scale, because, I mean, having just one storage server, at some point the disk will simply run full. Also, we were ingesting single events into MySQL, and we were doing all aggregations live there, which of course also became slow at some point in time. Yeah, and this whole handling these raw log messages with Python wasn't really feasible, or at least we wasted a lot of time there. But still, with this very simple setup, we succeeded in building a proof of concept and convincing some investors to give us money. So we were able to hire more people, have a bigger team, and of course, what do you do if you're stuck with your conventional SQL stuff? You go Hadoop. So let's have a look what we did to these particular problems that we identified. Okay, for the storage part, straightforward, we moved to HDFS, of course. But we still did like this, first of all, writing the data to a local disk and then eventually copying it to HDFS. For the problem with the live aggregations, we switched to an ETL process on top of Hadoop. We already back then basically used Hive on top of the gzip JSON files that were in HDFS to generate aggregates, which we then simply exported to Postgres. And for also some more complex reporting queries, we wrote some MapReduce jobs ourselves in Java. And for these analytics workloads, well, now we had Hive on top of the gzip JSON files, And it was finally possible to write queries on this data, on the raw data. This, unfortunately, also had we had problems with that because we were writing these files on the front-end servers, so we often had lots of small files, and you know lots of small files in Hadoop is a problem, which is why we sort of built a hack of materialized views in Parquet format, so that we were able to query the raw data faster. So this was basically an intermediate hack at this stage already. But eventually the system grew and grew, and also this setup had its problems, actually many of them. First of all, we were using JSON from the beginning, and I will come back to that later, but at some point we realized having this flexibility in JSON can be a huge benefit, but it can also be a huge pain because, well, you can't really rely on anything. I mentioned already we had this small file problem because basically the files that ended up in HDFS, they were generated on front-end servers, which, well, we had to find this trade-off between timely ingestion, like not waiting too long on the front-end servers until the files are big enough, and yeah, and managing somehow the file size of the ground truth raw log files. But still, we had no timely ingestion. Then, well, this is just a detail. We were really unhappy with the UZI DSL. It caused us a lot of pain. I mentioned it before, this whole ETL process was extremely slow because it was running on the raw data, but we really wanted it to run on the rawest data because we wanted to make sure that our reports are always based on the ground truth, which are our logs that we will never touch again. Also, these MapReduce jobs were really not a lot of fun to maintain. Okay, I mentioned that already. Okay, so what's next? Oh, there was one more. Of course, we had basically all our data duplicated, which is also not nice. How to fix that stuff? For the no reliable data structure part, we moved to protobuf. Oops. Well, you have a schema there, and this is something you can rely on. This becomes important when you have many teams working with the data. It becomes more important that people can rely on it. For the small file problem and the no timely ingestion problem, and we just heard about it again in the talk before, we moved to Kafka. Because that basically decouples the real-time component from this whole data pipeline, because the consumer of the events that come from Kafka can finally decide how much it will consume until it spills to HDFS. So we actually have much better manageability of file sizes in HDFS, which is actually still, I think, one of the most crucial parts, unfortunately, for optimizing query speed. Well, Uzi, just a tiny detail, we switched to Luigi, which feels much more productive. And for this whole MapReduce stuff, we started to change that to Spark, because it just also feels much more productive to work with. Well, now that we had this have this whole Kafka pipeline in place, we're actually able to write our data directly into Parquet format, which basically also solves the last few problems, because we're no longer forced to do our whole ATL stuff on top of gzip JSON, but instead we can basically do it quite fast directly on Parquet tables. And this also made this whole analytics workloads a lot faster, because, well, we can now use all the tools that are available now in the Hadoop ecosystem directly on top of Parquet tables. Good. So let's summarize that, the 3 stages. We basically managed to build a proof of concept without Hadoop. But we, of course, weren't able to scale that. But it was fine because we still, our main focus in the beginning was still our machine learning algorithms. It was not so much about scale. It was just about proving in a smaller scale that our technology actually works. But then eventually, of course, we had to move to something bigger, had to introduce Hadoop. And the biggest mistake that we did back then was basically that we kind of naively just thought, well, we will manage it, and we didn't really take a lot of consultancy or hire any experts. So we also did a lot of mistakes there, and this basically forced us to do another huge step of changes for finally being able to get to a scalable infrastructure. Maybe some numbers, just that you have an idea. In the first stage, something like 500 requests per second on average, just 10 gigabytes per day additional data set growth, which we handled with one server for a while. Then that basically all multiplied by a factor of 10 in each stage. So what are the main lessons that we learned in this process? I don't know, maybe some of you know this comic. So it's basically an analyst asking an engineer how to query the database, the new database, and the engineer replies, well, it's not a database, it's a key value store. Okay, it's not a database, how do I query it? Well, you don't query it because you write a distributed map reduce job in Erlang. And the analyst asked, did you just tell me to go screw myself? And the engineer actually realizes, well, probably he did exactly that. What we learned is that it will help you incredibly when you're really concerned with the data business, with a machine learning business, if you make all your raw data accessible through SQL. And if you make sure that it is accessible in a fast manner, because this will allow your data scientists to query that data and to look into it, and they will find out great things. And if they can't do it, then they will also not do it. And this is also why I think it's so great that we see so much progress on this whole SQL on Hadoop thing, and I also think that is basically the explanation on why we see so much progress on this SQL on Hadoop thing, because it's just so damn useful. And I'm also actually quite excited about what, for example, Apache Drill might bring here, because that just goes into the same direction. What we also learned is that you should probably leave other DSLs, like more complex ones, MapReduce, PIC, etc., to the engineers, because SQL is actually almost always good enough. There's one interesting exception which we are realizing at the moment, which is Spark. I mean, everybody's talking about it. Anyways, at least if they, or if we will see an improvement in the Python interface, that might be an exception to this rule of thumb, because it integrates very nicely into all these machine learning tools that many data scientists really love to use. Another lesson learned about introducing Hadoop. Well, maybe this is a bit outdated now. From my memories, it was quite a rocky road to introduce Hadoop 3 years ago. I think it has become a lot simpler. So maybe the barrier is much lower now. But you should really ask yourself, at what point in time do you really need Hadoop? Because usually, at least when you're doing machine learning, as a startup, you will not have big data because you don't have the customers. And the question is really, do you really need to build your whole infrastructure based on big data technologies right from the beginning before you have your first customer? So my answer to this question is simply, well, when conventional SQL stuff becomes too slow, then probably the weapon of choice nowadays is something Hadoop-based. Yeah, as I mentioned, many things can still be achieved without it. But when you do introduce this, unless you happen to have some Hadoop experts in your team already, make sure to find some, because that will allow you to avoid lots of mistakes that stayed around for us, with us for much longer than necessary. For example, the small file problem that I mentioned before, or big unsplittable files, which also slow down the whole thing, or MapReduce jobs that we wrote in Java, where we actually should have chosen a better, higher level abstraction. Another lesson learned. Data format. I think JSON is great because it's human readable. It's very flexible. You will need this flexibility in the beginning because you will change your product over and over again. You can even, I don't know, listen to TCP streams and parse it directly out of it because it's human readable and not binary. But at some point, it might also become a problem, and a format with a schema like protobuf or Avro or whatever might become beneficial, especially when you have a growing team. You need to maintain compatibility between the teams and components. But if you do introduce something like that, you should really make sure, and we saw that in the talk before as well, you should really make sure that you provide tooling for your users to look into this binary format, because otherwise you are sitting in front of your data. In the case you have to debug it and you just can't look into it. I linked a nice article by Twitter here, which also discusses this topic. All right, so before I conclude, let me talk a little bit about team, which also goes hand in hand with the technology decisions that we have seen over time. When you're bootstrapping, you're usually just a handful of founders and without money, and so you, I don't know if you saw the keynote this morning. Then it's Eric mentioned that you will always have very short runways. You will always have deadlines. So you better use the tools you're most productive with. Once you have some funding and you can afford hiring people, I would say it pays off to have a small team of generalists, because as I mentioned before, your product will change over and over again. So you rather have some people that are flexible and can change technologies and work flexibly on the product. So you also better use widespread technologies where you can Google all problems. But then, of course, at some point, eventually, for the sake of scalability, you will be able to build up specialized teams, or you will eventually write your own database, like many of the big companies. I don't know, Twitter built Storm and Facebook built Hive, etc. Conclusion. For building a machine learning company, yeah, first of all, most important thing, find the right product. Find something that has the potential to scale. Otherwise, you will not become a big data company, at least. Then don't underestimate the whole infrastructure development that you will have to do around your core machine learning ideas. This will take up a huge part of your effort. Something that we realized too late and which would have sped up a lot, provide fast SQL access to all your data at all time. Focus on this right from the beginning. When introducing Hadoop, either you already have an expert in your team, or find one. And also important takeaway, I would say, is start with a flexible yet and human-readable data format. And that's already it. I thank you for your attention, and I think, oh well, you can reach me on Twitter or email if you like. Otherwise, I think we have a few minutes for questions.
Okay. So